Okay, welcome everybody. I think this is about a minute and a half past, so I hope most registered attendants actually managed to join. My name is Elena Verdolini. I'm going to be moderating today's webinar. I am a professor at the University of Brescia and a senior scientist at the RFF-CMCC European Institute on Economics and the Environment. Today, we are very pleased to host Daniel Raimi from Resources for the Future and from the Gerald for the School of Public Policy at the University of Michigan. So Daniel is with us today talking about assessing the costs and benefits of decommissioning US oil and gas wells. I'm particularly pleased to have Daniel here because this particular presentation is part of what I would consider is one of his main streams of work, which is looking at issues that have to do with oil and gas regulation and taxation, as well as decommissioning. And more broadly, Daniel focuses also on climate change policy. So before I give the floor to him for his presentation today, let me just remind you let me tell you a few words about the RFF-CMCC European Institute on Economics and the Environment, which is organizing this webinar. EIE actually was born a few years back as the result of a partnership between RFF, Resources for the Future in Washington, D.C., and the Euro-Mediterranean Center on Climate Change in Italy. Both of these research institutes have done quite a fair share of work on economics, climate, and the environment over the past years. The RFF-CMCC European Institute on Economics and the Environment was born with the mission to improve environmental, energy, and natural resource decisions through impartial economic research and through policy engagement. And it's a testament to the fact that both RFF and CMCC would like not only to continue working on these topics, but also to work on them jointly and cooperating together. So a few ground rules for today's webinar. So you will have noticed that your audio and video are deactivated by default. This is because we are in webinar mode. In order to ask your questions to Daniel, if you have any, you have two options. I would suggest that those of you who can take the first option, namely using the Q&A section at the bottom of your screen, where you can actually type your question, and I will, at the end of the presentation, read them out loud for Daniel to reply. Should you have any issue with using this approach to posing your questions, please, in this case, use the raise hand button at the bottom of your screen, and hopefully there will be enough time to give you the floor and ask your question at the end of the presentation. So one note which I should tell to everybody is that this webinar will be recorded and it will be later uploaded on the CMCC YouTube channel, which you can find on the screen, the address of which you can find on the screen, as well as on the websites of CMCC and of the Institute. If you have any further questions about the webinar, please feel free to email webinar@cmcc.it. Last, I am also tasked with reminding you of the forthcoming webinar, which will take place on April 7th. The timing is 12:30 p.m. European summer time, as we recently changed our clocks. And that webinar is going to be on finding the right dam partners for a just energy transition. So without further ado, and having explained to you all the rules, let me give the floor to Daniel, who is going to probably share his screen for the presentation. Thank you very much. Daniel, you have about 35 minutes for a presentation.
Great. Thank you so much, Elena. And thank you to CMCC for inviting me to present in this series. It's an honor to be part of the series and really great to be part of the RFF-CMCC collaboration. I know we've been working with Elena on a variety of issues over the last year plus, and it's great to present on this particular topic, which has been very much in the news in the United States over the last year or so. So I'm going to talk today about some of the costs and benefits of decommissioning oil and gas wells in the United States. I'm going to focus on talking about onshore oil and gas wells, although offshore wells are another important and interesting topic. I'm really looking forward to your questions and your feedback. I'm going to be presenting on a few different topics today. To begin with, I'll just provide an introduction to the topic of abandoned and what are called orphaned oil and gas wells. I'll define those terms so that we all know what they mean, and I'll try to describe the scope of the issue so that we all understand some of the risks that these wells pose. Second, I'll talk about some key policy issues here in the United States, including policy issues that have led to the growth in the number of orphaned wells over time, and also some potential solutions to address the backlog of orphaned wells that currently exist in the United States, and also policies that might prevent new ones from becoming orphaned in the future. And then finally, I'll present some new research that I'm working on with colleagues at Resources for the Future, Jisheng Xia, Alan Krupnick, and Alexandra Thompson, and myself are working to develop new estimates for costs of decommissioning oil and gas wells in the United States. And I'll present to you some preliminary findings on that work. So to start off, let's define these terms and make sure we all understand what the difference is between an abandoned well and an orphaned well. So abandoned wells are all oil and gas wells that are no longer in use for some period of time. The definition of an abandoned well actually varies from state to state and from jurisdiction to jurisdiction. There is no single definition. Sometimes they are called idle wells, sometimes they are called shut in, sometimes they are called temporarily abandoned. But all of these types of wells are classified by the US EPA as abandoned wells, wells that are not in use for an extended period of time. They're not producing and they're not injecting. Some of these wells have been plugged with cement to seal them, and some of the surfaces have been restored. That is decommissioning a well when you plug it with cement and restore the surface, but many others remain unplugged across the United States. Orphaned wells are a subset, they are a type of abandoned well. An orphaned well is a well that has no solvent owner. At some point in history, it could have been in 1870, it could have been in 1920, or it could have been in 2005, the owner of that oil and gas well became insolvent, went bankrupt, and shed their responsibilities for taking care of and decommissioning these wells. When that happens, wells become orphaned. They are like little Orphan Annie. They are wards of the state, and it becomes the state's responsibility to deal with them. The US EPA estimates that there are about 3 million abandoned wells in the United States, and that 2.1 million of those wells are unplugged. So that is the broad universe of abandoned wells. Most of those wells have owners that are still solvent. However, the true number of orphaned wells in the United States is unknown. I'll explain why in just a moment, but there are currently records and documentation that identify about 57,000 orphaned wells around the United States in many oil and gas producing states. However, there may be 1 million or more undocumented orphan wells. That is, wells that we suspect were drilled sometime in the past, but records were not kept, and those wells probably have not been plugged in recent years. Now, if you think back to the early days of the oil industry in the United States, 1860s in Pennsylvania, you would see scenes like this, with dozens and dozens of derricks drilling dozens of wells. Record keeping was limited to non-existent. And so this type of drilling activity, which was largely unregulated and undocumented, is the type of activity that has led us to this problem of an unknown number of orphaned wells. Again, we know where about 57,000 of these wells are, but we suspect there are hundreds of thousands and maybe 1 million or more of these wells lying across the United States, and we don't know exactly where they are. So why do we care about this problem? Well, there are several reasons to care about orphaned and abandoned oil and gas wells. First, and the one that you've probably heard the most about, is that these wells can emit methane, a very powerful greenhouse gas. But in addition, these wells, if their casing and cementing has corroded over time, or if it's been stripped out, in many cases during World War II, people would strip out the steel casings from old oil wells and use them in weapons manufacturing. If there's no casing in a well, then that well can become a conduit for oil or other chemicals to flow into groundwater and lead to groundwater contamination. Third, well sites where the well pad has been cleared and the surface is not being used for typical ecosystem services are essentially foregoing the ecosystem services that we could gain if those well sites were restored back to their natural use or to some other useful purpose. Fourth, these wells could contribute to local air pollution. There is very little to no data on this particular issue, but if these wells are leaking methane, then it's reasonable to suspect that in some cases, they may be leaking other harmful air emissions that have the potential to make people sick. And then finally, these wells can be trip and fall hazards. Because many of the wells are undocumented and unmarked, there are plenty of stories of hunters in the woods of Northwest Pennsylvania or parts of Ohio or parts of Kentucky walking through the woods looking for deer, but they trip and fall into an abandoned oil and gas well or an orphaned oil and gas well, which can lead, of course, to injuries. Now, as I mentioned, most of the research focus on orphaned and abandoned wells has been on methane. And even here, there's fairly limited research to actually characterize the extent of the problem. Mary Kang, a professor at McGill University, is really a leader on this topic. She's been studying this issue for years. So I'd encourage you to check out her work if you're interested in methane emissions. But the central estimates from the US EPA are that on average, each abandoned, unplugged oil and gas well emits about 1/1300ths of a metric ton of methane per year. Now, the emissions are skewed to the right. So most wells or many wells emit close to zero methane, but a small number of wells emit a larger amount of methane. So this is similar to other issues in the world of oil and gas methane abatement. We have the so-called super emitters, which are a small number of wells that contribute the majority of the problem. So if we take the 2.1 million unplugged abandoned wells in the United States and we apply the EPA's average methane emissions factor, we get a rough estimate of about 276,000 metric tons of methane per year. If we use a social cost of methane of $2,000 per ton, that equates to about 550 million in damages per year, US dollars that is. And if we equate the methane to a carbon dioxide equivalent basis, we get emissions of about 9.5 million metric tons of CO2 if we're using a 100-year global warming potential of 34, or 24 million metric tons of CO2 equivalent if we're using a 20-year global warming potential of 86. And just to put that in context, Croatia's emissions in 2019 were about 18 million metric tons. So on the order of a small European country. Some recent research has estimated other effects that can be quantified when it comes to decommissioning oil and gas wells, not just the benefits of methane abatement. A recent working paper from Chapo estimates that property values in Pennsylvania are roughly $15,000 or 11% lower in homes that are within 2 kilometers of an unplugged oil and gas well. When those wells are plugged, she estimates that the costs are fully recovered, suggesting that there are some substantial property value benefits and societal benefits from plugging these wells. However, the mechanism for homeowners knowing about these wells is unclear. And having spoken with some folks in Pennsylvania, my sense is that people don't always know when they are actually near wells. So I think this is a really interesting paper, but it hasn't been peer reviewed, and so we'll see how it goes in the next couple of months. Another very interesting paper that just came out a couple weeks ago is from Hayden Champfosoy. I apologize, I don't know how to pronounce that name. Hayden Champfosoy et al., who estimate that the ecosystem service benefits of decommissioning wells would be about $49,000 per well. That is restoring wells to agricultural use or to other pre-industrial uses could lead to ecosystem service benefits of about $49,000 per well. And that does not include the methane abatement benefits that you would get. So 2 papers recently suggesting that there are pretty substantial benefits of cleaning up these wells above and beyond the methane abatement benefits. Now we get to the cost side of things. Costs are also not well understood with this issue of orphaned and abandoned wells. There is limited data from the Interstate Oil and Gas Compact Commission. This is an organization of state regulators in the United States who share information and best practices. Their data estimates that it costs about $24,000 per well to decommission a well. But if you look across the literature, the range of estimates is much wider than that. You see some central estimates in the literature of about $20,000 per well, and some estimates ranging to $100,000 or more per well. As I mentioned at the beginning, we at RFF are developing new estimates on decommissioning costs, which I'll describe in just a few minutes. So now that we have some basics on this issue of abandoned and orphaned wells, I want to mention a couple of policy issues that are very important in this domain. First, as some of you may know, oil and gas regulation in the United States is mostly governed by, by state governments. So state governments are the lead regulators in most cases, although the federal government is also the lead regulator in cases where wells are drilled on land that is owned by the federal government. So, whoever has jurisdiction, the states and the federal government require companies to provide financial assurance to decommission their wells in case they go bankrupt. That financial assurance can be provided in the form of a surety bond or some other financial instrument that provides funds in case the oil and gas company goes bankrupt and walks away from their well. However, the requirements, the financial assurance requirements, are typically far below the real costs of decommissioning wells. As I mentioned, decommissioning costs can range from a few $1,000s to more than $100,000 per well. Now, where this gets to be a really big problem, or at least a really big potential problem, is on the area of blanket bonds. Blanket bonds are financial instruments that allow, or they are policies that allow companies to post a single bond or financial instrument to cover every well in their state for one price. So let's say you're an operator in California and you operate 200 wells. You have the option to post a bond worth $30 million to cover all of those 200 wells. But if you're in Pennsylvania and you operate 200 wells, you can post a bond worth $25,000 that is supposed to cover the cost of decommissioning those 200 wells. You can see very quickly why this is a problem. Some of the states have blanket bond requirements that are far, far below, orders of magnitude below, the likely true cost of actually decommissioning their wells. So the implication is that if a substantial number of oil and gas companies go bankrupt over a short period of time, or even over a longer period of time, the state could be left on the hook for millions, tens of millions, or even hundreds of millions of dollars in decommissioning obligations. And as we saw in early 2020, when energy prices fall, more companies tend to enter bankruptcy and the population of orphaned wells tends to increase. For example, in North Dakota in early 2020, before COVID-19 hit and oil prices turned down, there were no orphaned wells in the state. But in February or March of 2020, they suddenly had more than 100 orphaned wells just in a period of a couple of weeks. So this is a problem that can grow substantially. And especially if we think towards the future, towards a net zero emissions world where oil and gas consumption is dramatically lower than it is today, you have the potential for millions of new abandoned wells potentially becoming orphaned wells, depending on how the future plays out. So there are two big issues here in my mind. I'd like to divide these up into two kind of buckets. The first one is, what should we do with the backlog of orphaned wells? That is the 57,000 wells that we know where they are and the hundreds of thousands more that we don't know where they are? And then second, how should we think about preventing this problem from getting worse in the future, in particular with an eye towards a net zero emissions future? So let's start with the backlog of orphaned wells. I co-authored a report recently with Jason Bordoff and Nilesh Nerurkar from Columbia University, in which we estimated that it would cost somewhere between $1.4 and $2.7 billion to plug the known inventory of about 57,000 orphan wells in the United States. We estimated that this activity would support about 11,000 job years, and we used a cost estimate of between $24,000 and $48,000 per well. We also estimated the cost effectiveness of methane abatement using this policy, and we came to a central estimate of about $170 per ton of CO2 equivalent using a 100-year methane global warming potential of 34. So this is certainly not the most cost-effective policy. If you wanted to reduce methane emissions cost effectively, orphaned wells would not be the place to start. Instead, the place to start would be the producing wells in areas where we know there are high methane emissions, such as the Permian Basin and other parts of the US oil and gas supply chain. However, plugging orphaned wells isn't a total loser in terms of CO2 abatement costs. $170 per ton of CO2e is at the high end of the US government's recent estimate of the social cost of carbon, but it is in line with some other estimates that have emerged in the literature in recent years. The most important thing to know about the numbers that you're seeing right now is that there is lots of uncertainty about every single one of these numbers. The number of jobs created, the number of orphan wells that exist, the costs of decommissioning these wells, and the methane emissions. There's substantial uncertainty about each one of these things. Nevertheless, there is lots and lots of interest in at the federal level in a federal program to plug orphaned oil and gas wells. President Biden talked about this considerably during the campaign. He mentioned it again just a couple days ago at a press conference, and there have been multiple bills introduced in Congress to tackle the known inventory of about 57,000 wells. One other really interesting development on this issue of identifying undocumented orphaned wells, that is the hundreds of thousands of wells that probably exist, but we don't know where they are. There are new technologies that have emerged in the last 5 to 10 years where we can use aerial surveys to survey areas where we suspect there are large numbers of orphaned wells and identify them using helicopters or drones and using LiDAR or magnetic imaging technologies. There's a really nice paper overviewing some of these technologies by Peckney et al. From 2018. And there are a variety of other papers that have come out in recent years. So those aerial surveys can help us identify where the wells are. However, existing methane detection technologies are not quite sensitive enough to detect the relatively low levels of methane that come from most of these wells. And so once you identify the wells, you still probably need to do a ground survey to identify which wells are leaking the most methane or posing the largest environmental hazards of other types, such as leaking oil at the surface or causing some kind of groundwater pollution. And those sites could be prioritized for decommissioning. Now, it's worth mentioning that implementing a program like this to identify potentially hundreds of thousands of additional orphaned wells, identifying this program or really any other program to get at the scale of this problem would require significant scale up of administrative capacity. In most US states, there is no existing orphaned well program. That is no state-funded program that is designed to identify, prioritize, and plug orphaned wells. However, there are some states that do have quite active programs, states such as Texas, Oklahoma, Pennsylvania, and several others, but those states are generally small, and historically they have not had the levels of funding that would be needed to identify the wells at large scale and really start to work through the backlog of the wells that exist. So those are a couple options for dealing with the backlog of wells. Now, how do we address the wells that are producing today that have solvent owners that we don't want to become orphaned in the future? Well, there are a few different options. Perhaps the most obvious option is state governments and the federal government could update their financial assurance requirements to reflect the true costs, or at least get closer to the true costs of decommissioning. That's politically difficult, especially in a period when oil prices are low, and especially in states where oil and gas companies have significant political leverage. However, a couple of recent studies from the economics literature from Judd Boomhauer, Ian Lang, and Redlinger show that increasing bonding requirements in Texas and in North Dakota had little to no effect on the ultimate amount of drilling that occurred in those states. That is to say, increasing bonding requirements probably will not be a crippling blow for oil and gas companies in the US. It could lead to some consolidation where more financially, where companies that are stronger financially, have stronger balance sheets, would be more able to absorb these new costs. So it could lead to consolidation, but the empirical evidence that we have suggests that it would lead to very little actually reductions in drilling. Another policy option would be for states or the federal government to introduce fees or standards. California has recently done this. Oil and gas operators could pay a fee for each inactive well. That fee might be $5,000 or $10,000 a year. And over time, such a fee would help incentivize companies to plug their abandoned and idle wells themselves, rather than leaving them for the state. Second, operators could be required, some kind of regulatory standard, they could be required to work down their backlog of inactive wells. So if a company has 100 inactive wells in a state, they might be required each year to plug 10 of those wells and reduce their backlog over time. Again, the policy specifics could be tailored to each state, but that's the basic idea. And then third, there could be some interest within industry to help deal with this problem. Companies actually plug tens of thousands of wells each year on their own. Many companies are good actors on this front, and they do take care of their environmental legacy issues. So there is, at least theoretically, a potential for companies to come together in order to protect their reputation, because this problem is becoming more and more of a public problem. There might be some industry interest in coming together to voluntarily address at least some of these wells. Okay, so I'll spend the last 5 minutes or so describing our recent work on estimating decommissioning costs here in the United States that we hope will inform policymaking. So as I mentioned before, there's significant uncertainty on how much it actually costs to plug these wells. So we were lucky, we reached out to a variety of regulators across the United States, and we gathered data from over 15,000 wells that have been plugged over the last 10 or 15 years from Kansas, Montana, Pennsylvania, and Texas. We're also working with one large oil and gas company that operates in the Permian Basin in New Mexico and Texas, and they've provided us with their proprietary plugging cost data. We matched these data to detailed well level characteristics using the company Enverus, which was formerly known as Drilling Info. So we were able to match many of these wells using what are called API numbers. So we know many of these wells' age, we know their depth, we know the type, that is whether they're producing oil, gas, or both oil and gas. And we know a variety of other things about these wells because we have their GPS coordinates. So we can identify certain characteristics of these wells at the surface. After going through this matching process, we were able to match about 4,000 contracts that were signed to plug over 7,500 wells. We use a log linear regression model to estimate costs with the log of costs on the left-hand side of the equation and a variety of variables on the right-hand side. These are the key variables that we're able to model using these data. I'll very briefly run through them. First, well depth. It's fairly obvious that the deeper the well is, the more material might be required to effectively plug the well. And so well depth is likely to be correlated with costs. Second, some wells are only plugged and the surface is not restored, right? Those are wells that are plugged only. We have other wells in our data set where the well is plugged and the surface is restored, that is brought back to some kind of agricultural or other productive use. And as you can imagine, there are different costs associated with carrying out both of those activities. Third, we are able to identify how many wells are on a given contract. That is, the companies that actually do these plugging services for state governments or for oil and gas companies, they contract to plug 1 well at a time, 2 wells at a time, 3 wells at a time, and so on. So we hypothesize that contracts with larger number of wells would offer economies of scale. Fourth, we wanted to know if there was a difference in plugging costs between wells that produce only gas or wells that produce some mixture of oil and gas. Next, it's plausible that state regulations could affect plugging costs differently in different states. So we use dummy variables to analyze the effect of plugging a well in each state. Second to last, we look at the age of the well. As I mentioned earlier, wells can degrade over time, and so we hypothesize that older wells will be more expensive to plug. And then finally, using geospatial data, we're able to estimate the effects of plugging wells in hillier areas relative to flat areas. So it's fairly intuitive. If you're trying to stand up a drilling rig or work on a well pad in a very hilly area, it probably just takes more time to set up your equipment and to operate effectively than it would if you're operating on flat land. So we're able to test that question as well. This is a quick look at the data. You'll notice on the y-axis, we've got a log scale, and on the x-axis, we've got a linear scale. On the left side here, we're looking at wells that were only plugged. That is, the wells are plugged, but the surface is not restored. We've got a little over 3,000 contracts where this was the activity taking place. The mean cost per well was about $20,000 to plug a well only. To plug a well and remediate the surface, we had a little over 900 data points, and the median cost was about $76,000 per well, so substantially higher. Maybe I'll just focus here for one more second on the wells. One of the really interesting things about the cost data here is that, again, it's a log scale. So even though on the left-hand side, the average is $20,000 per well, some wells cost more than $1 million to plug. And that can happen if you have a very complicated situation in the subsurface, or you have things like, leaks around the well site that have to be remediated at large scale. So I'll very quickly run through some of the results. What we found is that each of the variables that I described earlier are significantly correlated with plugging costs. So we found that each additional 1,000 feet of well depth increases plugging costs by about 18%. We found that remediating the surface increases costs by a little over double, so 114% increase. We found that there are economies of scale. Each additional well per contract reduces per well plugging costs by about 3%. We also found that gas wells are more expensive to plug than oil wells on average. We spoke with a contractor in Pennsylvania who plugs wells for the state plugging program, and they told us that this has something to do with what's called gas cut cement, or maybe it's water cut cement. I'm blanking on the name right now. But there are basically technical issues of dealing with high pressure gases that make it more complicated to plug gas wells than to plug oil wells. We found that plugging is more expensive in Texas and New Mexico than it is in Pennsylvania. The difference between New Mexico and Pennsylvania is quite stark, and we're still trying to figure out exactly why the difference is so large between those two states. We also found that older wells, as we hypothesized, are more expensive than younger wells. Wells that are aged 60 years or older cost 33% more than wells that are 20 years or younger to plug. And then finally, we find that this issue of elevation change also makes a difference. Each additional 10 feet of elevation change within 5 acres of a well site increases costs by about 4%. And if memory serves, so you have a sense of what an acre is, I think a standard football pitch is about 2 or 2.5 acres. So, a couple football pitches around a well site. Those are the detailed results. If you're watching this on video, you can pause and look at the coefficients and the standard errors if you would like. And now final thoughts before we go to Q&A, which I'm really looking forward to. So just final concluding thoughts. As I mentioned, there are millions of oil and gas wells in the US that are going to need to be decommissioned over the next several decades. Updating regulations by states and the federal government can provide better incentives to operators so that these wells do not become orphans, like the wells that we've talked about quite a bit in this presentation. For example, bonding levels could be updated to reflect some of the factors that I just described. Deeper wells could have higher bonding requirements. Wells in hilly areas could have higher bonding requirements. You could imagine other details that would reflect the likely true cost of decommissioning. But in all likelihood, to address the backlog of wells, public decommissioning programs will probably be needed at some scale. Those programs have the benefit of providing jobs for oil and gas workers, especially in an energy transition context, and they'll also provide environmental benefits. Again, the exact scale of those environmental benefits, we need more research to better quantify those, but they look like they might be pretty substantial. And then we need better information on a variety of topics when it comes to methane emissions, costs, and much more. So I will stop there. Thank you again to Elena and CMCC for the invitation, and I'll look forward to conversation.
Actually, thank you, Daniel. A very interesting presentation indeed, and we have a few questions which came up during your presentation. So I'm going to try and organize them a little bit. I guess that the first question you somewhat answered already with the empirical part of your analysis, but I think you could spend a few more words on this, which is people wonder, why is it so expensive to plug these wells? I mean, isn't it just about dumping in a bunch of cement, and of course it will be the more cement, the more expensive, and whatever not. So perhaps you could talk a little bit about that and the composition of costs associated. Is it mostly material cost, has to do with something else? This is something that people were wondering, why is it that costly to fill a hole?
Yeah, great question. And so I have never been on a plugging site. I would really like to. Unfortunately, I started working on this issue right when the pandemic got really bad, and so I haven't been able to go out into the field and spend time on a site. I'm hoping to do that sometime soon. But I have spoken with contractors and service providers that provide these services, and it's a fairly complicated process. So you can't just dump a bunch of cement down there. First of all, if you imagine a well that has degraded, for example, the cement is not necessarily going to stay in the hole. Second, you probably don't want to cement the entire length of the well, especially if we're talking about a 5,000, 7,000 foot well. That's a whole lot of cement that we're talking about. And so those costs could get quite prohibitive quite quickly. So what companies do is they send what are called wire lines, or basically monitors down the well site to characterize which parts of the well are most prone to cause problems, to cause groundwater pollution, or to cause leaks at the surface, to interfere with other wells in the area, to cause methane migration. And what companies do is they cement portions of the well. They don't typically cement the entire thing. And so when they do that, it requires basically a lot of expertise to be able to run the appropriate instruments, interpret them, and then precisely, target the parts of the well that you need to target. In many cases as well, companies need to do what are called fishing expeditions. So they sometimes have to lower equipment into the well to pull stuff out of the well. Oftentimes they'll find that, logs have been thrown down the well in the past, or pieces of tubing have been thrown down the well or have become dislodged. And in order for the cement to be effective, they actually have to go back down into the well and pull that stuff out before they can put the cement in. So it has the potential to be a quite labor-intensive and material-intensive operation.
Thank you. So there is a second set of questions, in fact, which is, let's say, perhaps related to the way in which, permits are regulated. in the United States. So specifically, people are wondering, you talk to us about certain companies operating in a large number of wells. They orphan some, they leave some of them, some of them they decommission. And the question that comes to mind to some of our, of the people in the seminar is, do you mean that actually you can get a permit to drill another well in a state if you haven't actually fixed the ones that you've already just abandoned? Meaning, can you basically, is it the case that they don't ask for you to clean up your mess before they actually allow you to make more mess or, dig another hole?
Right, I understand the question. So the answer is yes and no. It depends on how you define mess. So if a company has orphaned their wells, then that company has gone out of business. That company no longer exists. And so that company is not going to be drilling new wells because that company doesn't exist. But it is quite common for oil and gas companies to abandon their wells. That is, just kind of leave them be, let them sit and do nothing for periods of years and perhaps decades. And they could be allowed to drill new wells, even if they have wells that are sitting around doing nothing. Those wells are abandoned. Companies typically have to ask the state government for permission to let those wells sit idle for either a 1 year or a 3 year or some other period. But states almost always grant companies the ability to do that. So it is very common for some companies to have abandoned wells in their inventory, but also drill new wells at the same time.
Okay, and the question then comes to mind, what is the reasoning behind abandoning a well and letting it sit other than simply postponing the problem? And my question, let me be more specific. For instance, with fracking, right, with new techniques, is it possible that then companies go back and exploit those wells more within the next, the 3-year window or whatever? So is it really an economic decision that to let the well sit, or is it mostly simply, letting it sit so you don't have to decommission it, or you don't have to plug it, or you don't have to do something that is costly for you?
Yeah, I think in most cases it's the latter. So Lucia Muhlenbach's RFF University Fellow, I think she's at the University of Calgary. She's worked on this issue, and she's shown, pretty convincingly to me at least, that companies often have the financial incentive to sit on their wells because the cost of decommissioning them substantially exceeds the cost of doing nothing, especially if there's no enforcement down the road, or if those companies can eventually shed those obligations by going into bankruptcy proceedings, or maybe they'll sell the well. It's also not uncommon for larger companies to sell less productive wells to smaller companies, and then for those smaller companies to sell that well to another smaller company into the future. And so that these wells keep moving from larger to smaller operators, which increases the risks of them becoming orphaned in the future. As to your question of, could we go in and frack these wells? In some cases, the answer will be yes, but in most cases, well, I don't know about most, but in many cases, the answer will be no. The parts of the, subsurface where existing abandoned wells overlie productive shale oil or shale gas deposits, in some cases there's an overlap there, and in some cases there is not. So there are many orphaned wells in Northwest Pennsylvania, for example, that are not on top of the Marcellus Shale or any other productive shale deposit. But there are wells, let's say in West Texas, that are probably orphaned and abandoned that, at least in theory, could be deepened and hydraulically fractured. But you would need to talk to companies to actually understand whether re-entering a well and fracking it is more cost effective than just drilling a new well with modern technologies. My hunch is that it's probably just simpler to drill a new well.
Excellent. There is another group of questions actually that relates to more specifically the location of these wells. So there, for instance, somebody asks whether is it always the case that older wells are more costly to plug than newer wells, okay? Or that wells that are located, close to inhabited areas or cities or economic developed areas are more costly to plug than areas that are abandoned. Going on this sort of like stream of questions, there is also the real issue of why do people not report that they are living close to such orphaned wells? Is it possible that they are in places which are not populated, and therefore even the economic benefits associated with restoring that area would be, let's call them, marginal? Or is it because perhaps these communities are of lower income, right? And they may not, they may have bigger worries than to worry about the quality of life that they have around them. So basically, in the second circumstance, you would compound an inequality already existing with a further, with a further inequality because they are living in a substandard area from the health point of view.
Those are both great questions, and I'll try to take them in order. So, we do find consistently that age is correlated with plugging costs. So it does seem pretty clear that older wells will tend to be more expensive to plug than newer wells. And again, we hypothesize that's because of just the corrosion of a well over time. To the land use question, we actually tested for that in a set of regressions that we ran. There are a variety of ways to measure land use in the United States, and we used multiple data sets to test this question of whether it would be more expensive to plug wells in populated areas or more rural areas, because you could actually tell a story going either way. I can imagine it being more expensive to plug wells in a populated area because you have to work around streets and homes and power lines and things like that. But I could also imagine it being more expensive to plug in a rural area because you're farther from labor and equipment. And so you're just, operational costs are higher to get to that well. So we tested that, and we actually didn't find any consistent results with land use. And so we ended up excluding it from the regression for simplicity's sake. But, maybe there are, ways to get at that question that we didn't test, other measures that we could use that would help explain that dynamic better. It's a great question. And then, Elena, the question about whether people are aware or reporting the wells that are near them, I don't really know the answer to that. I think there's going to be a lot of variation around the country because some of these wells are in populated areas like Los Angeles, California. There are lots of orphaned wells in Los Angeles. And some of them are in very rural areas like West Texas or Kansas or elsewhere. And so I don't think we have comprehensive or even representative information on that question to answer it. The one thing I would say is that many orphaned wells, they're not always easy to see, especially the very old wells from like 1860 in Pennsylvania and Ohio. Those wells sometimes they're under the ground, like you can't even see them from the surface. They've been covered up over time. So I think it's entirely plausible for, at least in some cases, homeowners just not being aware that there are abandoned wells in their immediate vicinity.
So there is really scope, as you said before, for this new, aerial technologies or drone technologies to perhaps help in identifying this location, the sites of these wells. If you cannot spot them with just with your eyes, I guess that's also a challenge. There is another question that has to do with the statement that you made, which is, I'm going to read it. There appear to be some concern that bonding options could impact negatively on business prospect. Of course, this is business of drilling oil or gas out of the ground, which, we work for climate change in a certain sense. So if the business prospects are negatively impacted, it's probably not a bad thing from our point of view, generally speaking. So the question goes, surely that would be a benefit, or do you subscribe to the notion that policy instruments should best be single purpose and orthogonal?
That's a big question. I don't know if I'm ready to weigh in on that as a general rule, but it's a really interesting idea. In general, my preference is usually for the policy to address the problem that you're most concerned with. And so when it comes to the problem of orphaned oil and gas wells, I am most concerned about preventing more orphaned oil and gas wells. When it comes to the problem of climate change, I tend to prefer policies that specifically address climate change. So I guess I'm saying that I lean towards the single purpose approach, but I recognize the political constraints that exist in the real world, and for kind of the reality of overlapping policies, and to try to, make the best of the second best policies where they exist. So I don't think I can answer your question with a lot of precision, but I appreciate you raising it. I think it's a good one.
Yeah. So there is one other question that goes along these lines, and then I would like to go back to your results because we have questions on those as well, more specifically. Given the cost of environmental compliance and enforcement that could potentially bankrupt an operator and thus lead to orphaning the well, did you receive any feedback from regulators on the delicate balance of protecting the environment versus creating a new liability for the regulated public?
That's a great question, and I did talk to regulators about this. I was speaking with one of them, and I raised, sometimes people propose a kind of rapid scale up of bonding requirements for state regulators. So, increasing bonding requirements to, let's say, $75,000 per well, or something like that. When I raised that idea to the regulator, who has lots of experience, the regulator said, well, Daniel, if you do that, you're going to put a bunch of companies bankrupt. You're going to make a bunch of companies bankrupt overnight, right? The small oil and gas companies, and there are thousands of small oil and gas companies in the United States that operate 1, 2, 5, or 10 wells that are marginal to begin with. If you very rapidly increase the bonding requirements on those small companies, you're going to put them out of business very quickly, and you're going to end up with a lot of orphaned wells very quickly. So you have the potential to exacerbate the problem that you're trying to solve. What is the right answer? I think is something that I'm trying to figure out, and I think many others are too. Presumably, you would want to scale up bonding requirements or other financial requirements over time so that you don't kind of shock the system and lead to a mass orphanage, would that be the right term? A mass orphanage of oil and gas wells across the country. But the question is a very good one. Regulators are trying to balance this issue. California is the state that I think has been the most proactive on this in recent years. They've made some significant changes to their financial assurance requirements, and they've introduced these fees and standards that I mentioned earlier to provide kind of alternative pathways of compliance for different types of companies.
That's actually interesting to see because California, from us outside of the United States, always sticks up as the best kid in the class when it comes to climate in a certain sense. And apparently they're trying to do a good job also at getting out of the oil business at the same time, which is actually an important. So let me ask you, what are the non-financial barriers for upscaling public decommissioning programs and updating regulations? I mean, of course, there are financial issues. I think that is, in front of the eyes of everybody. It's a pretty obvious problem, but are there other significant non-financial barriers that regulators struggle with, or politicians in that sense?
Well, I think so. Financial is the biggest one. I mean, the oil and gas lobby is generally going to be in opposition to anything that raises their cost of doing business, and so the kind of connection of political and economic issues there would probably be at the top of the list. I think until recent years, there has also just been there hasn't been a lot of attention paid to this problem, and so it's partly been an information issue. I actually think it's still a little bit of an open question how high this issue of orphaned wells should rank on our list of environmental priorities. I think it's a really important issue. It's a fascinating issue. I have absolutely enjoyed learning more about it. But there are a lot of questions that I think we need to answer before we can say with certainty that this problem is our third or fourth most important environmental problem that we should focus on addressing. And I think that's one of the reasons that policymakers have not focused on it so much, is because other issues of carbon dioxide emissions and methane emissions from the existing oil and gas system and other environmental problems like clean air and clean water have taken precedent over orphaned oil and gas wells. My hope is that we're going to continue to get better information on this topic over the next couple of years so we can kind of appropriately prioritize it in the list of things that policymakers should be focusing on.
Yeah, I see the point of it not being, of struggling to understand where to put it on the scale, on the ranking of the important problems. However, as we move forward, if we actually manage to decarbonize, we're going to be dealing with a lot of similar issues in other sectors as well. I mean, oil wells are basically long-lived capital, which is not used anymore. It's not economical anymore, And so I think that it would be interesting, perhaps to also, this is not the time, but to also think about what other insights you could learn from similar problems in different sectors, for instance. I'm sure that there are specificities, but there are certain things that I think would be interesting to take along. So let me ask you if I managed to do that. There is a clarification question for your results, which says you refer to elevation change when you talk about the slope in the results, I think, as opposed to slope minus 4% is hardly a significant cost factor. So it seems slope hills is not a real factor to consider. You have GPS coordinates of the existing well. Isn't it possible to detect them via remote sensing?
I'm not sure.
I think that the point is on commenting. I think that the main point of the question is on commenting on the magnitude of the coefficient and its overall importance for the cost that you calculated. So you reported them as significant result, increasing by 4%. But is it really, is this 10 feet additional elevation so crucial? That I think is the question.
It's a good question. We actually tried to measure the slope, or we tried to measure this issue of elevation change in a variety of different ways. The reason we ended up using the 5-acre buffer area is because the GPS coordinates of the wells did not always precisely match where the wells were in the real world. So we just looked at Google Earth images compared with the GPS coordinates we had, and it was not uncommon for wells to be located maybe a kilometer or a half a kilometer away from where the GPS coordinates told us they should be. So we wanted to use this buffer to get a general sense of the elevation change in the area. As to whether or not these results whether they make sense intuitively for their magnitude, I think they do. When we spoke with companies that plug oil and gas wells for state orphan well programs, one of the things that they repeatedly mentioned to us was that plugging wells in hilly areas was more costly because it was more time consuming to sort of grade the surface before they went in and actually brought their rig on site to do the plugging. So it made sense to us. I'd be interested to interrogate it further if others have other ideas of how to measure this issue.
Specifically on the data that you showed us for the regression, I mean, I'm just throwing it out there because there is no more time to comment, but I think it would be worth having a discussion on the selection problem that you may have, given the fact that you only observe certain states addressing certain wells as opposed to others. So it'd be interesting to see in the paper, or in the report, a discussion on that, and how whether that provides a lower bound or an upper bound to your estimates. I think this is a very interesting question, given that you told us that only a fraction of the problem is actually addressed through state programs, and it differs by state. But let me leave you, if I may, with what I think is the toughest question that has been asked so far, and I'm not sure you will be able to or would want to reply, but the question is, can you name big listed companies which are either very good or lagging behind in managing well decommissioning?
I would answer that question if I knew the answer, but I don't. One of the issues with this problem of orphaned oil and gas wells is the lack of information. And part of that lack of information is a lack of companies providing transparent reporting on their plugging and decommissioning activities for their wells. So I would welcome companies, doing more to. If there are companies that are really good actors on this, I think it would be great if they would share their story. I think it would be good PR for them. And it would implicitly highlight those who might not be so good actors. As I mentioned, we did work with one, large oil and gas company who provided data to us. I can't tell you who they are, but I think they're a pretty good actor. But I also don't know what I don't know. So there's a lot of uncertainty on that question.
Yeah, but this speaks again to the power of information, you know, in moving forward for decarbonization. I think that not only data, but also, you know, transparency when it comes to this type of programs is really crucial. So Daniel, we are one past, so we pride ourselves in keeping the webinars within the time. I think it was a great presentation. I think that you know, the participants were actually very engaged. On my side, I hope I did a good job at presenting the questions that they had for you, but in case I did not, I urge all of you to email Raimi, and you know, if you have further questions or if I didn't portray your concerns in the right way. I remind you that there is a further webinar on April 7th. I would like to thank Daniel again for taking the time to be with us today. And I wish you all a good afternoon if you are in Europe, or a good rest of the day if you are in the US. Thank you very much to all.